Hello, I'm Mr. Troha. We're going to be talking about impact craters today. So have some nice images of different craters that are around the solar system. So a couple of terms you should be aware of. One is impactor. That's the thing that's actually impacting the planet or the object. And then ejecta is the displaced material that's going to be surrounding the crater after an impact. We're going to look at this slide for a little bit. These are the kind of 4 stages of a complex crater. And so the impactor would hit the planet or the object, and this ejecta would go flying away. At that time, there's these shock waves would ripple through the material in the planet or the object that was hit. But a lot of this stage is just releasing this debris that's flying out. Now, as we get into B and C, these are kind of similar, but that wave of that shock wave that goes into the ground ends up returning, and because of the high energy of the impact, some of the material gets melted, and so as that wave energy comes back, it ends up pushing some of the melted material up. You see that in slides B and C, how we have that central peak starting to form. Meanwhile, the ejecta is starting to fall down and collect on the outside edges of where the impact zone was. Right, and then D, that pile of ejecta has now sloughed down a little bit, and into these areas we have this melt layer where it's kind of flattened out because it was melted, and then they have this central peak from the rebound zone. Here are a couple of pictures of some different craters. We have this here, we have this ejecta. We see down here is very dramatic ejecta rays coming away from the crater site. There's an activity that we do when we're in the classroom. It's this upper left here where we take some flour and then we sift some cocoa on top and drop marbles and things in from different heights. And you can see the cool patterns that emerge from the ejecta coming out. So that's something you can do at home if you like. This is just a slow motion of a steel marble going into sand, and so you can see some of that crater being formed and then the ejecta on the outside. So one of the things about craters and things, they help us tell the age of a picture or of something we're looking at. So let's say we can't bring any rock samples back. That's pretty difficult to do. That's all right. We aren't able to get an absolute age, but we can get a relative age of how things happened by looking at this picture. If you notice, I've labeled these A, B, and C. Which ones happened first, second, and third? Well, if you look, these things can overlap each other based on how old they are. So because B and C are inside of A had to have happened first. Can't exactly tell, but I'm looking at C, and C has some additional craters here, so I'm saying C was second and B would be third. Let's start cross-cutting and superposition. These are things, other ways that we can tell the age. Sometimes there's additional features that happened. Superposition is when things are laying on top of each other or overlapping, and so much like we saw in that last picture, how there are little craters inside a bigger one. And cross-cutting is when you have something that's going across or cutting through, as the name suggests, channeling through different objects. Notice here we can look and try and figure out what are the relative ages, which one happened first, second, and third in A, B, and C here. All right, so B is cross-cutting. It's going through A and C. So what that tells us is that had to happen after A and C. Actually, we can't, it's kind of difficult at this point to see which happened first. But I would argue that A was first and then C was second and B was third based on maybe the pattern or the erosion pattern that it looks like from A. So crater classification, excuse me. I just mentioned the word erosion, that breaking down of material. Happens on Earth a lot faster because we have wind and rain. Out in something like the moon and areas that do not have the atmosphere, you aren't going to see that erosion. It would take a very long time for those things to happen. But it still does happen, and so the appearance of the crater can tell you how old it is. So here's a situation. Which one of these surfaces is older? The one on the right or the one on the left? Well, it's the one on the right is older. How do you know? Crater density. The one with more craters is typically the older one. Now, we have to assume, in this case, that we're having a constant rate of impacts over time, and there isn't some event we don't know about. But given that assumption, and the one with more craters would be the older. A couple of famous impacts. We don't always get to see the impacts of these things and the craters that happen, but this is one from the Peekskill meteorite. I'll show a video on that in just a second. The Barringer crater. This is in Arizona, and notice this bottom picture, this little area. They were really lucky that they didn't get hit by the crater, right? 50,000 years ago. That's a joke, by the way. But this created this amazing huge crater, 50 meters across was the meteor, and now the crater is 1.2 kilometers in diameter, so it's huge. The Tunguska event, which was in Siberia, the object broke apart before it hit the ground, and the blast was 1,000 times larger than what was at Hiroshima. So it blew out windows several hundred kilometers away. Peekskill meteorite. This was in 1992, so not that long ago. 12 kilogram stony meteor, and we captured it on video from multiple angles. Let's watch that video here. So, well, so it's coming in, and it'll cut to the scene here. It's coming across. Obviously, it's broken apart. It's flying in, lands in Peekskill, New York, and ends up with that picture we saw earlier, where it crashed through somebody's car. But that meteorite was then sold for $70,000. How about that? All right, the Chicxulub is what I say. It's was that big meteor that came in. This is the one that supposedly caused the mass extinction of the dinosaurs. Happened in what's now what we consider the Gulf of Mexico, right at the top of this area, and a 200-kilometer diameter crater. So effects all over the world from that. Here's a very bad animation, but I thought it was kind of funny. The KT asteroid impact. The Shoemaker Levy, number 9. This was a huge impact on Jupiter and left a ginormous scar there, so that would be something. So all these are ones that you could research for your brochure, possibly. All right, thank you very much. That's a little bit about craters and impacts, famous impacts. So enjoy the next video that we get to see. Have a great day.